This video will briefly discuss signals and signal handlers on UNIX. I will first go over a brief introduction to signals and signal handlers, and then show an example in C and Python. A signal is a software interrupt and is a very basic form of inter-process communication. It's an asynchronous notification sent to a process. A signal handler is code that is executed in response to a signal. So when a process receives a signal, it is possible to set it up so that a signal handler will get executed. On UNIX, signals can be handled in one of three ways. You can either use the default signal handler for that signal, which is specified in the UNIX system. You could ignore the signal, do nothing, or you could have a programmer-defined signal handler function that will get executed when the process receives that signal. Every process has a signal set, and that signal set specifies the various signals and the corresponding actions. And in C, on the CentOS system, the GNU compiler, the signal data types and system calls that we're going to be using are the SIG action structure, which is the structure that's used for signal action, and we'll talk about a few of those fields briefly. And then three system calls. SIG action is the system call that allows you to actually change the action for a specified signal. But first you have to initialize the signal set. And you initialize the signal set either to empty, to exclude all signals, or to be full, which means include all signals. So the SIG empty set will exclude all signals, and the SIG fill set will include all signals. So here's a very basic function. If we go down a little bit, we can see that main just does a print statement and then waits for 30 seconds and another print statement and ends. I've defined a signal handler function here called cleanup, and it takes one parameter, your signal handler, in C, which is the signal number in this case, and I'm just going to print that signal number out with another message, and then I'm going to end my program because the signal that I'm going to work with is interrupt, and so I just want to do some cleanup. This would be an opportunity to close files or sockets or free memory, etc. before ending the program. So the code associated with the signals with this C program is first I'm going to have this structure here, the SIG action, the structure that's going to store some of the information for the signal. Then I'm going to do a memset, which sets the memory for that structure to all zeros. These are the two setups for the signal action structure. First, we're going to set the handler to be cleanup. So what this does is in this structure, it's going to set the handler to be this signal handler function. And then I want to do a SIG empty set so that I'm excluding all of my signals initially. And now here is where I actually set my signal handler for a specific signal. So I set my signal handler here to this cleanup function, which I've defined. And then if the SIG action is the system call, and SIGINT is the signal that I want to capture, which is the interrupt signal, or Control-C from the command line. I'm going to use this SIGAct structure that I've defined, and then the third parameter is going to be null, which is some flags. But if we do a man page on SIG action, you can see what these are. The signal number, which is SIG int, which is some defines that are in the header file, then my signal action, and then the third parameter is sorry, not the flags, it's actually the old structure if you want to restore that at some point. But we're not going to worry about that for now. We're just going to set that to null. So I'm going to say for this signal, SIGINT, which is the interrupt signal, I want to perform what I've set into this structure, which is essentially this cleanup system, cleanup function. And then when we look at the man SIG action again, if we look at the return value as we've discussed, it returns 0 on success and -1 on error, and error no is set. So what that means is I'm going to check to see if it's not successful, if it's not 0, Then I'm going to call p_error to print out my user-friendly error message, and then also the operating system specific error message if there's an error with that signal. So when I run this, if I run this function, you can see my main, I get beginning program. And then if I'm going to do a control C, you will see that I caught the signal number 2, which is the signal number identified in the header file for SIGINT. It's a signal, the number associated with that signal. And then I just print do program cleanup and exiting, which you can see, this is what I have in that cleanup function. I caught this, I print out the signal number I caught, and then I just say doing program cleanup and exiting, and then I exit. So if we run that again, we'll see that that's when I get the control C, that's what's going to happen. What I'm going to do now is do this beginning program. You can see it's beginning program, and then I just let it sleep for 30 seconds. So I'm just going to let that run for a moment here. And then what I should get is this printf, no signals ending program, and the return 0, so the program should end. So if I don't do the interrupt signal, the program will continue after that sleep, and I will not run the cleanup function. So I will not get the print statements from the cleanup functions. So as we're waiting for this, just a reminder, a signal is a software interrupt, or a very basic form of inter-process communication. So we can send asynchronous notifications from one process to another. And then the signal handler is a function that's defined that is called when a specified signal is received by the process. And so now you can see after it did the sleep, we got this print statement that said no signals ending program, and the program finished. Now if we look at the Python example, again, signals are the same for Python. The concept of signal and signal handler is the same. In Python, what I'm going to do is I'm going to import this signal library here, and then I define a handler function. And again, I'm just going to do some print statements. I'm going to print the signal number, and just do another program that the program's another print statement that the program's exiting, and then I'm going to end my program with the erroneous slash there. But I'm going to end the program. In my main, I'm just going to print a statement very much like the C that I'm running the program. I'm going to sleep for 30 seconds and then print that it ended if there's no signals. So I'm going to run the program first and just let it run while I continue to discuss this a little bit. So you can see we get this running program. Now you will notice in Python there are 2 parameters to my signal handler function. The first one is the signal number, and the second one is the current stack frame. So you can pass null there, or you can pass a frame object. So I have it defined, but I'm not using that frame object at this point. So if we sit and let this time sleep 30, now the program's running. So what should happen is I should get the print statement, no signals ending program, and you can see that that has happened. When I run the Python program and I do control C, now you see again my signal handler function was run. I caught the signal number 2, I do my other print statement, and my program ends. So again, it's very similar with Python. I have a signal handler function, and then here's the way that I specify that signal handler function to be associated with a specific signal. So it's the signal system call within the signal library, and I do a signal.sigint. Again, that's a define for a specific signal number for that interrupt signal. And then I'm specifying the function name that I want to be run when this process gets that signal. Very similar to the C code, we use a sig action system call here, which sets up my cleanup system call, which I've defined into the structure. And for the interrupt signal, I run that sig action. And so again, just another reminder, a signal is a software interrupt, a very basic form of inter-process communication, because it's just a notification that can be sent, a specific notification that can be sent to a process. And then the signal handler is the code that is executed in response to a specific signal. So hopefully now you know a little bit more about signals and signal handlers on UNIX, and how to program those with C or C++ or Python.